Now in module 5, we are going to learn how to use reference geometry like plane, axis, point and coordinate system. In this module, we'll learn how to create reference planes, axis, point and reference coordinate system. After going through all of these, we'll have a rigorous practice on all of these 4 points. In command manager, especially on future command manager, you'll find reference geometry, under which we have a plane, axis, coordinate system, points and other. SolidWorks offer you default plane like front, top and right in design feature manager tree. They are only good for creating the features perpendicular to each others. They are not good enough to create the given complex geometry. For example, look at this figure. Here, to create this circular geometry, I have to create an inclined plane at certain angle from the reference surface or the default plane. So sometimes it's a need of a complex geometry. So planes allow you to create sketches and feature on orientation other than the default front, top and right planes. It is essential especially for loft and sweep, where the profile are changing from sketch to sketch. So you require a reference plane. So they are helpful to create a very complex and multiple sketch profiles. Sometimes planes are required to create mirroring, or you can say symmetry. So you can easily mirror the features. So again, they are very helpful in assembly. For example, you have a 2-cylinder, right? So they are assembled into one another, one having slot. Now when you assemble it, it may happen that their default planes are not matching, but you want to orient this slot in particular direction, then you can use their default planes, front, top, and use them to align and mate them properly. If they are not available, then you have to create the reference plane for the same purpose. So it is easier. It offers a flexibility in design. When you invoke the reference geometry, especially plane, you need to choose references, first, second and third. Most of the time you require 2, but at least you need to provide 1 reference to create a plane. So depending upon the selection of first reference, that is edge, face, plane, vertex or curve, you are able to create a plane parallel, perpendicular, tangent, at an angle and offset to the reference surface. So when you have a complete selection of references, this will turn into fully defined state. It will be in green color. Now in exercise number 5.1, we have one block of 50 by 50. You can create it. Now on this block, we are going to create different 4 planes and try to create a geometry and try to understand how to create these planes and achieve the desirable results. So let's switch to SolidWorks. Now create new part file. Click OK. Make sure the unit is in millimeter. Now on top plane, I'm going to create center rectangle having dimension of 50. Now extrude by 50 distance. Now let's create the first plane. So click on reference geometry and plane. The first plane is going to incline at 30 degree to this top surface. So my first reference is this edge. Now plane property manager will immediately switch to the second reference. So I will choose this top surface. So by default, SolidWorks itself assume that you want to create a perpendicular plane passing through this edge. but we do have other options. Inside it, I'm going to choose this angle. Here I'm going to enter value 30. So SolidWorks let me create a new plane passing through this edge and exactly at 30° to this surface. So here we do have one more options. If I click on flip offset, so it will change the direction of inclinations. It goes on bottom side. If you want to create more planes, let's say not one, so there are two more planes, means one is 30°, second is also 30° from the first plane. So let's go to only one and again go back to the upper side inclination and click OK. So now we have one plane. Now let me open a sketch on it. Let me draw a circle over here and dimensions. So let's align with vertical directions and distance is 20. Okay. Now let's extrude. Change the directions and select up to next and click OK. So we have created a cylindrical features incline on a plane 1, which is at 30° from the horizontal surface. Now let's create another plane. Now this time I want to mirror this feature exactly at the bottom. So for that I require a plane which is exactly at the middle. So for that I will choose reference geometry and plane. So this is my first reference. I will rotate the model and I will choose the bottom surface. So immediately SolidWorks realize that you want to create a mid plane. So look at under reference, this is mid plane and mid plane. Now it says fully defined. So go ahead and click OK. Now let's try to create a mirror. So select the mirror command, though I haven't taught you the mirror command, but it's very simple, straightforward. So select the mirror plane. In our case, it is newly created plane. We do not have any second plane. Now we want to select the feature you want to mirror. So here we have this circular part. So look at it get mirrored at the bottom. Go ahead and click OK. So we have used the newly created plane for mirroring or patterning the feature. Now let's create third plane. So go to the reference geometry, select the plane. This time I will choose this corner and this corner, and the third point will be this. So SolidWorks will create a new plane passing from these 3 points. So look at on the left side on property manager. So we have chose 3 different vertices. So from those vertices, SolidWorks created new plane. Click OK. Now on this plane, I will open a new sketch. Now let's draw a circle of 10 millimeter diameter. Okay. And I will select extrude. I will change the directions. You can just keep it whatever you like, distance value. I'll keep it 40. So here I have created new feature which is on plane 3, which is created passing through from 3 vertices. Now let's create plane number 4. So go to reference geometry, click on plane. This time I will choose this front face. So automatically it assumes that you want to create a parallel plane. But here this time I am going to give a distance of 30 millimeter. That means the newly plane will remain parallel to the selected surface but at an offset distance of 30. If you wish, you can simply flip the offset. It will go inside the object, but I want outside. If you want multiple parallel plane for loft and sweep feature, you just go ahead and add the number of planes. But here I want only one. So I'll go and click OK. Now on this, I will open a sketch. And I will draw a circle having diameter of 10. keep it vertical and extrude it. Now reverse the direction. This time I'm going to add angle, outward angle, right? Let's say 10 degree and click OK. So I have a object which is created on plane 4 and extruded up to this surface. So this way you can choose various points and edges and reference surfaces to create new plane. Like plane, you can also create a reference axis. It is just available in reference geometry below the plane. Sometimes this reference axis is also known as construction axis. It can be used as axis of revolution for creating features such as a revolved and circular pattern. A temporary axis are those created implicitly by cones and cylindrical in model. So here what you see is temporary axis. It can be turned on by clicking on display button on heads of toolbar. So to create a reference axis, you need either edge, a line, or existing axis, two plane, intersection of two plane, vertices, cylindrical surface, conical surface, or point or face. So combination of these two, any of these two will help you to create the reference axis. Now here under the reference axis property dialog box, you have 5 options which you can use to create the reference axis. With the help of 5.2 exercise, we will learn how to create various axes. Now in this object, first I am going to create axis 1 using front and right plane. And with the help of this axis, I am going to mirror this feature. After that, I am going to create axis 2 using cylindrical features. Now, to create the axis number 3, I will use this vertex point and this vertex point. And using that axis, I am going to create a normal plane at this location and I will create these cylindrical features. And lastly, I will going to create axis 4 using over here the edge and the face. Okay. So let's try to see all of this in SolidWorks. Open the file called 5.2. Here we have one block with conical surface. So let's create the first reference axis. So go over here and choose axis. Now for the first selection of a reference entity, inside that I will choose this option, two planes. So here I will choose front plane and the right plane. So these two planes are intersecting at this location, and from that intersection a new axis is created. So click OK. So you can see the axis is created. Now from heads up toolbar, you can turn on this view temporary axis on and off like this. Okay. If it is cylindrical surface, if you click it, look at this temporary axis is visible. If you don't want it, you just turn it off. Now let's try to mirror this conical surface on this right side face. So for that we have to choose circular pattern. Now as a reference direction, we have to choose newly created axis. Here we have to choose the feature you want to pattern. So in our case, this is the cylindrical surface. Now reverse the directions and change the angle to 90. Go ahead and click OK. Now let's create second axis. So go to reference geometry, select the axis. This time I will use this fourth option, cylindrical or conical face. So go ahead and select that part and right click. So we have axis 2. Now using axis 2, I'm going to pattern this on a top face. Go ahead and select the circular pattern. As a part of direction, choose this axis too. And for feature, select this conical surface. Reverse the direction and angle the 90. Enter the value of angle 90 degree and click OK. Now let's create axis passing through from 2 point and vertices. So select this point and rotate your model and select this and right click. Now let's create a plane perpendicular to this axis at this vertex. So go ahead and click on reference geometry and plane. First you select this vertex, press Ctrl and select the axis. So that will create perpendicular plane to the axis 3. And go ahead and click OK. Now open the sketch. Here I will draw a circle of 10 mm diameter and extrude it. So you can choose the end condition and click OK. Now let's create axis number 4. Here let's choose these options, face and this point. So newly created axis is perpendicular to selected face as well as passing through from the selected point. Go ahead and click OK. Now let's say I want to create axis number 5. Passing through from line, edge and axis. So this time I'm going to select this edge and right click. So new axis is created which is passing through from this reference edge. Now what is benefit of this axis? Because they are being referenced to while creating, when the reference changes, their location is also changes. So reference plane and axis are very useful for creating pattern, mirroring of features or creating the inclined features on a surface. Now let's learn how to create a reference point. Now reference points are basically used as a construction object. Under the reference geometry, you'll find the reference point. When you start creating the point, its property manager will offer you 6 different ways to create the points. One is arc center, center of a face, intersection, projection, on a point, and equidistance number of points. Means you can create number of points. Look at over here, the first option, which is arc center, center of the face, intersection, right? Sorry, projection, intersection, equidistance point, and a point on a curve. So let's practice this exercise 5.3. Now open the exercise 5.3. Under the reference geometry, choose point. Now remember, there can be a confusion over here. Under the reference geometry, there is a point, and also under the sketch, there is a point. These two are different. I will explain the difference while practicing the exercise. But in nutshell, these sketch points under the sketch, they remain inside the sketch. They are 2D by nature. While under the feature, reference points are in 3 dimensions. You can assign the points in y3 coordinates. Now let's go under the reference geometry and select the points. The first point is arc center. Let's say you want to create a reference point using this arc. So select this arc and right click. So it will place a reference point exactly at the center of this arc. So you can use this point to connect with the other geometry. So point will be referred as reference point. Now let's try one more. Now this time I will choose center of a face. Now I have this shape. I want to create a point exactly at the center of the face. So choose this. So SolidWorks will find center of this shape. It can be irregular shape, rectangular face, pentagon, anything. it will help you to find the center of a profile. And go ahead and click OK. Now let's try one more options. This time I will choose intersection. So this one and this line. So these two edges are meeting over here, and I'm able to create a point on an intersection. Now let's go ahead and explore another options. Now here we have a projections. So what we have is select this face and select this reference point. Okay. So it will project this reference point on selected face. Go ahead and click OK. So moment this profile change, the location of this point will also change. So let's try to change the value of a reference profile. Look at this, the point 4 is also move up. Now let's try other options of creating points. On a point, here I have a curve. Exactly on the end, I want to add a point. That's what is called on point. Means you can have any curve like arc, spline. You can just midpoint or end. You can just assign that location to create a new point. Right click. Now if I change this, let's say I want to edit this sketch and I want to move like this. If I exit, obviously the location of point 5 is also moved because it is on an endpoint of a curve. Now let's try to explore last options. Go ahead and click on point, choose these options and select this edge. Here I have a 1 point from this vertex at exactly 10 millimeter away. If I want to create few more, I can add the value here, number of points 3, 4, 5. You can also add the value by percentage or evenly distributed, means it will choose the entire length and divide into equal length. Let's go ahead and create 6 points and click OK. So evenly we have created these 6 points. So this way you can create a reference point which can be used for referencing the other features. Now fourth is creating coordinate system. Basically, coordinate system is mainly used for machining or analyzing a model by positioning the origin of model related to its feature. But in case of CSW exam, the coordinate system will help you to find the center of mass. It is also useful to find moment of inertia about any reference axis or reference axis of a selected coordinate system. We'll try to explore this creating the coordinate system through a model. Now let's practice the reference geometry through exercise. Open new part file, click OK. Set the unit to inch. Now in exercise 5.4, we need to create a feature which is inclined at 30 degree from horizontal surface. Let's first create a base plate on a front plane. So pick the line command. Now give the dimensions. This is 3. This is 0.5. Press S and select the extrude. Now this time I will choose mid plane, right click, and the depth is 4. Now choose this and convert it to entities and try to create center point arc. Now let's extrude. Select up to reference, up to surface, and select this surface. Okay, and click OK. We need to create a plane. So select the reference geometry and inside that plane. The first reference is H. Second reference is this plane. And under the second reference, choose the entity called angle. Now enter the value 30. So I already have a 30 value, and go ahead and click OK. Select this and select the sketch. Here, let's draw the geometry. So from here it is first line, second line, and there is an arc, and I'll come back to this point. Now select this midpoint and select this origin and make them vertical. Now let's take these as 2.5 as given in the figure, and the length of this is 3, which will fix the diameter of this circular arc. Also add a circle over here whose diameter is 1.5. Just rotate your model and see we have created the geometry on inclined plane. Go to feature, select the extrude boss base. Now select blind first. Okay. Now it is moving in wrong direction. Reverse it, and this time choose up to next and click OK. So press Ctrl 7. Now in case if you required this hole to be a through hole, then you have to create this sketch separately and then extrude cut. But as of now, I'm just leaving as it is. So through creating reference plane, you can model such part. Now for the exercise 5.5, open new part file. Make sure unit is changed to IPS. Now look at the figure very carefully. Here, to create a very small offsetted cylindrical feature, we need to create a separate plane. And on that separate plane, we need to create this geometry and we have to extrude it. Though this part can also be modeled in different way. But as of now, to strengthen the concept of creating plane, we'll only try to complete this exercise through plane creation. So go ahead and create a sketch on a front plane. So draw center line, then a shape like this, and dimension them. Here this diameter is 8, this diameter is 7, overall height is, press escape to change the from diameter dimension to linear, and click OK and add the value 10. Now this value will be, obviously it is as given, 8 minus 7 is 1. Okay, and half of that is 0.5. So this value is 0.5. And go to features and click on revolve. Click OK. Now here what we have to do is to create this cylindrical feature, we need to create a plane parallel to the default plane at a value of 6. So go ahead and select the reference geometry, select the front plane, it will immediately offer you a parallel plane options, but we need to enter offset distance of 6. Go ahead and click OK. Again, open the sketch on this plane. Draw the circle, another circle, and dimension them. And provide the reference distance, which is 1.5, and from bottom it is 2. So let's first create a cut feature. So I will choose inside circle, and I will choose up to surface option and choose the inside surface. So it will create a cut. Now reuse that sketch and click on extrude. Here, reverse the direction and choose this and up to surface. Right click. So what we have is exercise 5.5. Now, because the plane which we created is at a distance of 6, so we can change this value. Based on that, the dependent geometry is also updating. For the next exercise 5.6, open the given part file. Now here we have to create a cut over here, which is angled at 30 degree from the horizontal surface. Now this time I will turn on this view of temporary axis. So that will create an axis of a cylindrical surface. Now I am going to create a plane like this, passing through from this temporary axis as well as inclined to this surface and at an angle of 30. So look at the figure very carefully. I don't want this kind of inclination, but I want to offset it. So this is the plane I want. Now click OK. Now again, I have to create a cut over here. So I need a plane perpendicular to the plane 1. So go back to the plane creation, select this plane, and second option is this temporary axis. So obviously in the first reference, the plane is perpendicular to plane number 1. But in second reference, it is also passing through from temporary axis. Click OK. Now on this, I am going to create a sketch. Okay, so select this plane and create the sketch. Sometimes object get rotated in the awkward position. So press Ctrl and use the arrow key, 4 arrow key, to rotate the model. Now here I am going to use a slot tool like this. And as given in the figure, I am going to dimension them. Because already the dimension is added while creating the slot, I will just add it to the required value. This will be 1.75. Because all the planes are coming in a way, let's hide them and look at the normal to the sketch. Again, press Alt and left arrow key to orient it. Now, because it is not fully defined, that means we haven't fixed the location of slot. So choose this point and click this edge and coincident. Now it is properly fully defined. Go ahead to the features and select the extrude cut. Now here on direction 1, I have to choose up to surface. So this is my surface. Okay. Now on direction, turn on the direction, and again inside that up to surface, I have to choose same surface again, right? So our sketch is exactly in center. So we are going to create a cut up to the outer cylindrical surface in both the directions. If you go and select the through wall, it will also cut this corner point. So mind well which option you have to choose inside the cut feature in property manager. Go ahead and click OK. Cut. So this way, by using axis and reference planes, you can create a cut feature. Now for the exercise 5.7, open new part file and make sure the dimension is in inch. So on a front plane, open the sketch. This time I'm going to draw like this. Okay, let me make this horizontal. Let's draw circle. Now let's dimension them. Outer is 1. Inside circle diameter is 1. From here, this is 4. Now here, the sketch still we have provided the complete dimensions to fully define the sketch, yet it is not getting fully defined. The reason is this endpoint is not tangent. So select them and make them tangent. Okay. Now let's extrude. This time I will change the direction in opposite side and enter the value of 2 inch as given in exercise. Now let's open a sketch on a top plane. This time I will draw the center line from mid to mid. Now choose the corner point over here and over here. Select this, control and select this line and this. Okay. Give the value. Now this is from this edge, it is 3. Go ahead and cut that part. Okay. Now let's create the surface over here as given in exercise. Now first, let's go to on top and create one more sketch. This time I'm going to draw line over here. Okay. Now what are the dimensions? So from here, it is 1. And from here, it is also 1. Go ahead and cut that part. Make sure, because it is open sketch, and mind well this small arrow is pointing outward, or it is in the direction of a material which we want to remove. Okay, so this is in right direction. Click OK and cut it. Now we want to create another cut flat surface. For that, we have to create 2 sketch points. Select over here and here 1 point and second point over here. Now let's give the dimensions. So the first point is from this, it is exactly at 2. And the bottom is from this edge is 1. Okay. Now select the top surface and open the sketch and place the point over here. Now we are placing the points which are inside the sketch. It is not reference geometry point. Click exit. So we have 3.1, 2 and 3. Now let's create a plane passing through from all these created points. Okay. If you wish, you can avoid creating this third point and directly you can just go ahead and select this vertex. So that will save a time. Now we have to create a sketch here to remove this part. So how can we do that? So for that, under the sketch, under this convert entities, we have intersection curve. Select this face, this face, this face, this face, bottom face, okay, and select the plane and click OK. So this will create a 3D sketch, which is basically intersection of a plane and this part. Now let's extrude and cut it. Here we need to provide a direction. So this is our directions. So let's flip the directions. So automatically SolidWorks picked up this 3D geometry, and we have now remember while creating the 3D sketch and extrude and cut features, you need to provide the direction because it is by nature it is 3D, so it doesn't know that by normal extrude features or 2D sketch it always goes perpendicular, but here being a nature of a 3D environment, it doesn't know where to go, so we need to provide the vector. So let's go ahead and click OK. Now hide the plane. So here what we have done is we have just created the 3 points in a sketch. Then we have created the plane, and with the help of intersection curve, we created 3D sketch and then we extruded it.